So show you results of some of their experiments, since they have the results easily available on the web. Now, when this paper was written, which was a while ago, they were running 30 frames per second on a 320 by 240 image. So now it can go faster because time passes and machines get faster. They were also only using 500 possible samples. That's 500 possible new proposals. Now maybe you could do 5,000. They used 50 eigenvectors. Maybe you could use more. The idea is the actual numbers don't matter. The goal is it was nice and it was kind of in real time. In fact, that's why I put down it runs at XXX frames per second using MATLAB, where XXX is going to be more than 2 and less than 90,000. So it's in there somewhere. Depends on how fast your computer is. So here's some results that they show you. Now up here, this is the main image, and you can see they're tracking the face there. What you're going to see here is going to be mostly about where the image is being explained best. We're going to talk about that more when we talk about occlusion. And what you're going to see down here are about 10 of the eigenbases, right? And you're going to see that they're changing as the appearance changes. So if I press, there we go. All right. And so you can see that it's doing a pretty fine job of explaining the face, of tracking the face. That middle row that I was talking about, that has to do with what am I seeing versus how well can I reconstruct it from the basis set, and it's using that as its evaluation. And you can see with really large lighting variations, it tracks really well. You saw it got stuck there at the very end, and that sort of as far as it could go. Yeah, here's another example where you're going to see a lot of sort of change in orientation and change of appearance. And this is Sylvester the cat being tracked. And you can see that it creates a lot of really sort of creepy looking Sylvesters on the bottom. Those are the eigen cats, the images of the thing. And that's how it's doing its tracking.